We're going to start with scalars and vectors, right? And I'm going to explain what are scalar quantities, what are vector quantities, and then we will move towards the vector resolution, right? So let us begin. Scalars and vectors, right? I'm going to start with the very beginning, and then we'll move towards the resolution of forces, right? You should know that scalar quantities are physical quantities that can be represented by a magnitude only, right? They do not have any direction at all, right? Scalar quantities are physical quantities that can be represented by magnitude only. They do not have a direction. What we mean by magnitude is, for example, you have a car which is moving a certain distance, for example, 5.0 meters. So here 5 is what? That is the magnitude, right? This is the magnitude or the value, right? Similarly, if there's a car which is moving at a speed of 25 meters per second, you do not know that whether it is moving towards right or it is moving towards left. That is only the magnitude that we're talking about. So if a car is here and the speed of the car is 25.0 meter per second, it's just the speed that we're talking about. It's a scalar quantity. We have different examples of scalar quantities, which include what? For example, we have mass, we have temperature, we have the electric current. Electric current is, by the way, scalar because it does not follow the rules of vector addition. So it's not a vector, it is a scalar. We have power, work, volume, pressure, energy, distance, time, intensity, and many more, right? Since all of these quantities that I've talked about, they have only the magnitude which matters, right? And they can be easily added. For example, you can add two different distances. You can add two different work done, right? For example, you can add 5 plus 25, that will give you the simple answer, that is 30. 30 meters. If you add two distances, it's going to be 30 meters, right? So the addition is very simple. As far as the vectors are concerned, the vectors are a bit different. Now, what are vectors? I'm going to talk about them. You should know that the vector quantity has, number one, magnitude, and number two, it has direction. For example, we have a car, and for example, this car is moving towards the right, and it is moving at a speed of 80 meters per second. If we align the magnitude of the speed with the direction, it becomes a vector. It becomes velocity, right? We have magnitude, we have direction, and when we sum up both of these things, that becomes a vector, which is the velocity. Similarly, if you have a particle here, it goes on like this all the way from here to here, right? You know that this is the distance traveled by the particle all the way like this, since it goes like this all the way, right? This entire path that it has taken is the distance. However, if you go directly from A to B, that is displacement, distance which is moved in a specified direction. So this is the displacement that we have. This is the displacement, and this one is the distance. And I've already told you distance is a scalar and displacement is a vector. How do you define a vector? A vector can be defined by an arrow diagram. Now you see here that this is the head of the arrow, and this is the tail of the arrow, right? And to explain it further, a vector wholly is described like this. For example, this angle is theta. The length of the arrow will represent what? It will represent the magnitude. If the length is greater, the magnitude is greater, right? The length of the arrow or size determines the magnitude. And number two, this angle represents what? It represents the direction where it is going, right? angle represents the direction. So vector quantities, कौन सी हैं? I'm going to talk about that. There are different vector quantities. Some of them you will study in AS, some of them you will study in A2. But to tell you the truth, here are the vector quantities. Velocity is a very common vector quantity. We have displacement. Any other vector quantity that you can think of? All forces are vector quantities. Force is a vector quantity. We have acceleration, which is a vector quantity. Momentum is a vector quantity. We have moment of a force. Moment of a force. We have torque. I'll explain the difference between moment and torque later on in the chapters, right? There is a difference between them. Torque is for more than one forces, moment is of one force. We have momentum. We have the electric field strength. This is something that you'll study in A2. Magnetic flux density, again, you'll study that in A2. And we have gravitational field strength. That is also a vector quantity. If there are two vectors, for example, a vector is like this, and the vector can be represented like this, A with an arrow. Somewhere you'll not see an arrow, right? But they will tell you that it is a vector, right? So for example, you have a vector like this, and it has direction here, theta. And there's another vector which is like this, and it has direction theta. If the two vectors have the same size and the same direction, these vectors are equal. If the two vectors have the same size, which is the magnitude, and they have the same direction, remember that they are equal. However, if you have a vector like this, for example, this is vector P, and you draw a vector which is entirely the opposite of this, what is this vector? This is minus P. You have changed the direction altogether. However, you can also draw it like this. If you have a vector P here, and you draw a vector which is like this. Now this vector is K times P. This vector is K times P, where K is a number, right? And if you draw a vector like this, it is going to be minus Kp. I hope this is clear. There are various ways to add the vectors. It's not that simple as that of the scalar quantities, right? Where we can just add simply. Here we have different methods to add the vectors, and we call this coplanar vector addition. As you can see here in the formula, in the syllabus, right? That we've talked about understand the difference between scalar and vector quantities, and give examples of scalar and vector quantities included in the syllabus. We've talked about this. I'm going to talk about add and subtract coplanar vectors. Coplanar vectors are those vectors which are in the plane, one plane, right? And then we have the vector resolution. So let's talk about this, and then we can move on. There are two methods to add the coplanar vectors. One of the methods is the head to tail rule. And a little bit of extension of this rule is the parallelogram law of vector addition. So head to tail rule is the basic rule we have, and parallelogram law comes from that, right? Let us talk about head to tail rule first. I have a vector which is vector A like this, and I have another vector which is vector B, which is somewhere like this. Now what I have to find is I have to find the resultant of these two vectors. I have to find the resultant. I mean, if I have two forces, one force is going in this direction and one force is going in this direction, I need to find the resultant of these two. Now what you'll do is, one of the simplest method is that I'm going to number these vectors. I'm going to number this vector 1, I'm going to number this vector 2, or I can number this vector 2 and I can number this vector 1. It's up to me, it's totally up to me. Now what I'm going to do is the head of the first vector. So I'm going to draw this vector like this, exactly like this. And this is the head of the vector 1. The head of the first vector, it's going to join with the tail of the second vector, like this. This is vector 1. This is vector 2. The head of the first vector joins with the tail of the second vector. And the tail of the first vector joins with the head of the first vector. The tail of the first vector joins with the head of the second vector to give you the resultant. The head of the first vector joins with the tail of the second vector, and the tail of the first vector joins with the head of the second vector to give you the resultant, right? This is the rule. आप वेक्टर 2 को वेक्टर 1 भी कर सकते हैं. मतलब मैंने यहाँ पे a और b लिया, मैं b को वेक्टर 1 कर देता हूँ. फॉर एग्जांपल मैं अगर वेक्टर b को 1 कर दूं, मतलब मैंने वेक्टर b को पहले बना दूं इस तरह. दिस इज वेक्टर b और वेक्टर a को मैं यहाँ पे लगा दूं इसके हेड के साथ, which is like this, right? तो आपके पास एग्जैक्टली उसी तरह की ओरिएंटेशन आएगी. ये देखिए रिजल्टेंट बिल्कुल वैसा ही आ रहा है. ठीक है. The head of the first vector joins with the tail of the second vector, and the tail of the first vector joins with the head of the second vector to give you the resultant. I'm going to write this rule here. The head of the first vector joins with the tail of the second vector, and the tail of the first vector joins with the head of the second vector to give the resultant. Now we have various questions in the past papers where we have things like these. For example, you have been given this question is from summer 16. I'm going to do that, right? But before that, for example, you have a vector x. For example, you have this vector x and you have vector y here, right? What they'll ask you in the exam, they'll say that find the vector z such that z is equal to x minus y. ये कैसे करेंगे आप? You'll invert the direction of y and you'll apply head to tail rule. What you'll do is आप y की direction invert कर देंगे. आप y को minus y को किस तरह करेंगे? आप minus y बिल्कुल exactly ये कर देंगे. ठीक है? और आपके पास जो इसका आंसर होगा वो इस तरह से होगा. आपने वही रूल अप्लाई करना है कि x के साथ y की टेल लगाए यहां पे लाइक दिस. इसको आप उठा के यहां पे रख दें और इसका टेल इसके हेड के साथ करें तो आपके पास वेक्टर z आ जाएगा. सो आपने क्या किया? आपने x और माइनस y को ऐड किया ताकि आपके पास वेक्टर z आ जाए. लेट अस डू अ क्वेश्चन. अच्छा जी, सो इफ यू सी हियर, दिस इज a question from summer 16 paper 1-3. They have given you vectors p and q. You have to represent the vector p minus q. What will you do here? You will invert q. Very good. This is going to be minus q, and then you'll apply what? Head to tail rule. So what I'm going to do is मैं minus q को उठा के यहाँ पे रखूंगा और मेरे पास जो इसको जरा मैं थोड़ा सा, क्योंकि इसका मैग्नीट्यूड देखें बड़ा है, आपने मैग्नीट्यूड का ख्याल रखना है. और आपके पास क्या आ जाएगा? तो ये क्या बनता है? C is the answer. This is as simple as this. एक और क्वेश्चन before we move ahead. This question is from November 19 paper 1-1. Let's do another question. The diagram shows vectors x and y drawn to scale. If x is equal to y minus z, which diagram best represents the vector z? You have been given x is equal to y minus z, and you have to find the answer for this. What you have to find is you have to find the value of vector z. We have x is equal to y minus z. In a situation of this sort, I'm going to make z the subject. This is going to be z is equal to y minus x. So this is in fact y plus minus x. You're going to add minus x into y. So what I'm going to do is I'm going to invert this like this. This is minus x. This is going to be minus x. And the head of the first vector joins with the tail of the vector. So the answer is A. उसका हेड उसके टेल के साथ मर्ज करें, इसका टेल इसके हेड के साथ मर्ज करेंगे, you'll get the answer. और इसी तरह के P2 के क्वेश्चंस भी आपको जब आएंगे तो उसमें आपने यही करना होगा, और आगे उसके मैग्नीट्यूड कैसे निकालना है उसके दो तीन तरीके हैं, मैं आपको बताऊंगा. एक तो स्केल डायग्राम है और एक कोसाइन रूल है और साइन रूल है. ठीक है, लेट्स टॉक अबाउट दैट. पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन. पैरेललोग्राम law of vector addition. You have an object here. There's a force of 50 Newton acting here. There's a force of 30 Newton acting here, for example. I'm going to draw it like this. And the angle between them is, for example, 40 degrees, right? If they ask you that find the resultant of this by using a scale diagram, you have to draw the scale diagram, right? So for a scale diagram, your first step would be what? You'll choose a scale. You'll choose a scale for this, right? And the scale would be what? What is the convenient scale that you will choose here? 1 centimeter represents 10 Newton. The convenient scale that you will choose is 1 centimeter represents what? 10 Newton. And what you're going to do is that you're going to draw a line which is like this. This is a 5 centimeter line. You'll use a ruler to draw this line. This is a 5 centimeter line. Then you will use a protractor here and you will draw a line of 3 centimeters at an angle of 40 degrees. You'll draw a line of 3 centimeters at an angle of 40 degrees. You'll repeat the same here. You'll draw a line of 3 centimeters at an angle of 40 degrees. Why? Because this angle and this angle, they are both corresponding angles. Both of these angles are corresponding angles. So automatically you'll see that this line is gonna, this end is gonna meet with this end, and these two lengths are going to be parallel and equal, right? What you're gonna do is, in order to find the resultant here, you will merge this end with this end, right? ये diagonal आपके पास एक बन जाएगा इस तरह से, right? Line एक बन जाएगी इस तरह से, from this end till this end, and this is going to be the resultant, right? अगर आप गौर करें तो ये वही चीज है, हेड टू टेल रूल ही है. इसका हेड यहाँ पे, इसका टेल, इसकी टेल, इसका हेड. They are the same. And what you'll do is you will measure its length. For example, if you measured this length, okay, the length is, for example, whatever the length is, you'll measure it with a ruler. For example, the length is 6.4 centimeter. For example, then the magnitude of the resultant would be what? Of the resultant is going to be 6.4 times 10, because 1 centimeter represents 10 newtons. So this is going to be 64.0 newtons, right? This is going to be 64.0 newton as the magnitude. And how will you measure the direction here? If you want to measure the direction with the horizontal, you will use a protractor to measure this angle, theta. And you'll say that the direction is theta degrees, whatever the angle is, you'll measure it, right? For example, it can be 17 degrees, it can be 14 degrees, whatever you'll measure with the horizontal. And you can also measure this angle as well with the vertical, right? ये वाला angle भी आप measure कर सकते हैं. आप 90 में से इसको minus कर दें, या आप ये वाला ही angle measure कर लें protractor से, it's up to you. अगर आपने ये angle, ये वाला angle measure करना है with the vertical, ये vertical है, देखें, this is vertical. If you want to measure this angle, what you'll do is you'll write it's 90 minus this theta. इसको आप करें, इसको आप alpha कह दें. This angle is alpha, so alpha is 90 minus theta, and that is with the vertical के साथ. तो I hope कि ये आप लोगों को clear है. अच्छा, sometimes what happens is that they ask you to find the resultant without drawing a scale diagram. For that, what you'll do is you will use the cosine rule. That is the most convenient way. If we'll do vector resolution later on, but you can use the cosine rule here, right? Cosine rule. So for example, I have here a vector which is A, and I have a vector which is here, which is B, and the angle between these two is, for example, theta. You have to find the resultant of these two vectors and you have to find the magnitude of that. What you're going to do is you can draw the parallelogram as we did before. What you can do is you can draw a line like this and you can make a parallelogram like this, and this is the resultant as you can see here. ऐसे ही अच्छा ये साइड आपको गिवन होगी, ये वाली साइड भी आपको पता है दैट इज बी, ये वाली साइड अगर बी है तो ये पैरेलल होगी, इसके बी इक्वल होगी। अच्छा अगर ये एंगल पूरा थीटा था तो ये भी थीटा होगा, ये दोनों कॉरेस्पॉन्डिंग एंगल्स हैं। अच्छा ये वाला एंगल क्या होगा जो इंक्लूडिंग एंगल है, ये वाला, दैट इज 180 माइनस थीटा, दैट इज 180 माइनस थीटा, राइट। आप 180 में से इसको माइनस कर दें, इसको आप सी कहते हैं इस एंगल को, ठीक है, इसको हमने सी कह दिया। अच्छा अगर आपने इस रिजल्टेंट को मैं सी कह देता हूं और आपने इसका मैग्नीट्यूड निकालना है, व्हाट यू डू इज you have this very famous formula which is c square, which is the side c is equal to a square plus b square minus, you can draw a bracket here, it's 2 times ab into cosine of the including angle between two sides, right? That is going to be cos c. And what you can do is you can take the under root here. This is a square plus b square minus 2ab cosine of c, and you can find the answer for the resultant, right? This is what the cosine is. Let us apply this in one of the questions. Actually, this question here is that an aircraft is traveling in wind. Figure 1.2 shows, this is one of the questions from the past papers. Figure 1.2 shows the velocities for the aircraft in still air and for the wind. The velocity of the aircraft in still air is 95 to the west, and the velocity of the wind is 28 meter per second from 65 degrees south of east. Okay? On figure 1.2, draw an arrow labeled R in the direction of the resultant velocity of the aircraft. You have to find the resultant of the aircraft. What will you do? Just draw it. So इसका एक तरीका, आसान तरीका ये है कि आप इसको एक्सटेंड करें ऊपर की तरफ इस तरह, ठीक है। और मैंने बताया था कि फर्स्ट वेक्टर, फर्स्ट जो आपको ये फर्स्ट वेक्टर है वो ये नजर आ रहा है, इसका हेड ये, इसकी टेल ये। The resultant is going to be in this direction. This is the way that you can do it, right? The head of the first vector joins with the tail of the second vector. The tail of the second vector is this, and the tail of the first vector joins with the head of the second vector to give you the resultant. Now this is 95, this one is 28, and this angle is what? That is going to be 115. Can you find the value of resultant using the cosine rule? It's very simple, right? In the next part, determine the magnitude of the resultant velocity of the aircraft. They've asked you, and what you'll do is you're going to apply the cosine rule. So you have c square is equal to a square plus b square minus 2ab times cosine of c, and once you'll put in the values, you'll be able to find the answer for this, right? A square is what I'm going to talk. This is, for example, 95 square plus 28 square minus 2 into 95 into 28 times cosine of 115. You'll take the under root afterwards because you'll have to diminish this part c square. So you're going to take the under root like this. And the answer for this is 109.8, which is approximately equal to 110, because आपके पास यहाँ पे जो है वो आपने सिग्निफिकेंट फिगर्स का ख्याल रखना है, राइट? ठीक है, यहाँ पे डेटा में आपके पास जो है वो 2 सिग्निफिकेंट फिगर्स हैं, और यहाँ पे आपके पास यहाँ पे भी 2 सिग्निफिकेंट फिगर्स हैं। आप 110 कर दें, 2 कर सकते हैं या 3 कर सकते हैं, जो मिनिमम डेटा में होता है उतने या उससे एक ज्यादा आप कर सकते हैं, राइट? ठीक है, सो द आंसर आई एम गोइंग टू राइट हियर, इट इज 110 मीटर पर सेकंड। दिस इज हाउ यू विल अप्लाई द कोसाइन, राइट? And there is another method which is the sine rule. And that is also sometimes very convenient. And what you can do is, for example, you have here angle A degrees, this side is A, this is B degrees, this is B, this is C degrees, and this is C. What you can do is you can write here A over sine of A is equal to B over sine of B is equal to C over sine of C. So if you've been given two sides and one of the angles, you can find the other angle, right, or other side, right? जो भी आपके पास है. So these are the basic tools that you're going to do in order to solve the vectors. And the next big thing is resolution of vectors. ठीक है?